Welcome back. This is question 2b of Z transform. In this question, we are interested to interpret this equation which converts xn to xz. We see that the conversion of xn to xz is simply multiplying xn with a sequence of z minus n and sum it up all together. And we do it for all z. What does it mean? We can actually interpret this from a dot product. So let's devise what a dot product is first using this equation. A dot product deals with two vectors, vector A and B, or U in this example. A dot U comes out a scalar, and this scalar is defined as the norm, which is the length of A multiplied by the norm of U. So it's norm of A multiplied by norm of U, multiplying by cos theta, where theta is the angle between these two vectors. So in this example, A is a vector and U is a vector, and theta is the angle between them. Now, to interpret it even more carefully, what does norm of U do? Well, let's make norm of U to be a vector 1 first. So this becomes 1. So A dot U is simply the norm of A cosine theta. You can then now think of it this way. A dot U, when U is a normal vector of length 1, a vector of length 1, then it is the length of A multiplied by cosine theta. This is the value that you will find. It is a scalar that will tell us how much length of A can be represented by vector U. The larger this dot product is, it means that A is closer to U. That's the key idea. Now, if we have different U, we can measure how A behaves with different U. So in fact, this is exactly what the Z transform Z is. The Z here is the different ruler that we can use, different U that we can use to measure xn. Why is this so? Because the expression of A dot U can be written as this way, where AI represents the element of A's, UI represents the element of U. So if you look at this equation of the A dot U, the dot product, it is identical to this equation actually. Well, in this case we can do small n, and then for finite sequence we'll see that they are exactly the same. So let us now do a simple example where we only consider a causal sequence that have 4 samples, x0, 1, 2, 3, and we expand this equation. Summation of n equals to 0 to 3, x of 0, z minus n, xz. Therefore we will have this equation over here. So we will have x of 0 multiplied by z of minus 0, x of 1 multiplied by z of minus 1, and so on and so forth. We can then write it as the vector x dotting with the vector z, where this z represents this sequence of 4 numbers here. So Z transform in this interpretation is simply taking the input sequence x, dotting with different z's, where z is constructed by different values in the complex plane. And we will see that different z's generating a sequence is nothing but a complex exponential, whether it's decaying or growing, rotating anti-clockwise or clockwise according to our previous question. Why is this interesting and important? It's because when we can do it for all of z, the entire z plane, then we have converted a sequence in time to a surface of xz. And this surface represents xn directly in another different form. But in this surface of xz, many useful properties such as convolution becomes multiplication become true. Okay, so I hope that now you have a different interpretation of xz, and it will serve as a useful understanding in the future. Thank you.